There was a time when a new AI model release felt like a major event. One company would publish a benchmark chart, the industry would spend several days debating it, and everyone would argue about whether the model was smarter than the one that came before. Now, the releases arrive almost on top of each other. OpenAI announces GPT 5.6 Sol. Anthropic introduces another frontier model. Meta reveals what it has been building. XAI enters with its own claim to the top of the leaderboard. The entire industry reacts like spectators at a horse race, watching four powerful machines sprint around the same track and trying to decide which one is half a length ahead. But while everyone is staring at the finish line, the race itself is changing. The important question is no longer which model can produce the smartest answer inside the chat window. The more valuable question is whether that model can leave the chat window, enter a real business process, and finish the work. Can it investigate a problem, use several tools, recover when something fails, remember what happened an hour ago, and continue moving toward an outcome without requiring a human to guide every step? That is the larger meaning behind releases like GPT 5.6 Sol. The AI industry is beginning to move beyond machines that speak intelligently and toward systems that are expected to act intelligently. We are moving from language models to digital workers.
Imagine hiring the most intelligent consultant you have ever met. During the first meeting, this consultant understands your problem immediately. They ask excellent questions, see patterns everyone else missed, and produce a beautiful strategy document before lunch. You leave the room impressed. Then Monday arrives, the consultant does not contact the finance team, they do not update the spreadsheet, they never open the project management system, check whether the supplier replied, or notice that the customer data is incomplete. Whenever something unexpected happens, the work stops and comes back to you. The consultant is brilliant, but every useful idea still has to be carried across the finish line by someone else. That is how most companies have used AI so far. The model creates the email, but a person sends it. It explains the software bug, while an engineer still needs to locate the files, change the code, run the tests, and deploy the fix. It drafts the research plan, yet a human remains responsible for finding the sources, resolving contradictions, writing the report, and updating it when new information appears. This kind of assistance can save enormous amounts of time, but it does not fundamentally change how work is organized. Autonomous agents promise something different. Instead of handing you a map, the system begins driving the journey. A coding agent might inspect the repository, identify the likely source of an error, make a change, run the tests, examine the failures, revise its approach, and prepare the completed work for review. A research agent could gather evidence, compare competing claims, create a report, and continue refining it as new information appears. The economic difference is enormous, an answer is useful, a completed outcome is valuable. The first personal computers were often compared by processor speed. Faster chips mattered because they expanded what the machine could do. For a while, speed became the easiest way to explain progress. Eventually, however, businesses stopped buying computers because one processor was slightly faster in a laboratory test. They cared about the software, security, reliability, compatibility, and whether the system helped employees get real work done. The processor remained important, but it became one part of a much larger machine. Frontier AI models are moving in the same direction. They are becoming incredibly powerful engines. But an engine is not a car. Without steering, brakes, suspension, navigation, and a driver who understands the destination, more horsepower can make the vehicle more dangerous, rather than more useful. This is the mistake many companies are about to make. They will buy the strongest available engine and assume that autonomous execution will naturally follow. It will not. A model may be capable of reasoning across a difficult problem, but a real business process contains far more than reasoning. It contains permissions, missing information, outdated documents, conflicting instructions, unusual exceptions, failed integrations, and decisions that nobody remembered to include in the official workflow. The intelligence inside the model may be extraordinary. The road around it is still full of potholes. A chatbot can make a mistake in a few seconds. It gives the wrong answer, a person notices, and the interaction ends. An autonomous agent can carry that same mistake for 6 hours. Perhaps it begins by selecting the wrong customer account. Nothing immediately looks broken, so it continues. It reads the wrong documents, updates the wrong records, creates a report based on incorrect assumptions, and sends the work into the next stage of the process. The original error may have been small. Autonomy gave it distance. This is one of the least understood aspects of the coming agentic era. Longer execution does not merely require a smarter model, it requires a stronger control system around the model. Even a system that performs individual steps well can struggle across a long chain of dependent actions. Reliability compounds in the same way that small navigation errors compound during a long journey. A ship that is 1 degree off course may appear to be traveling correctly when it leaves the harbor. Hundreds of miles later, it reaches the wrong coastline. That is why autonomous work needs checkpoints. The system must know where it is, what has already completed, whether the evidence still supports its plan, and when the situation has changed enough to justify stopping. Without those safeguards, intelligence simply allows the system to travel more confidently in the wrong direction. Human workers do not operate on intelligence alone. A new employee joins an organization and receives a role, a manager, a set of permissions, access to specific systems, and an explanation of what requires approval. They learn where information is stored, which policies matter, and who should be contacted when something unusual happens. The company surrounding the employee makes useful work possible. AI agents need their own version of that company. They need clear responsibilities rather than vague ambitions. They require permissions that match the job, not the full range of what the model is technically capable of doing. Their actions must be visible, because an organization cannot manage thousands of digital workers if nobody knows what they are doing. Memory has to be designed carefully, so the agent remembers useful context without preserving every misunderstanding forever. Recovery also matters. When an application fails, the agent needs to know whether it can continue, retry safely, or return the work to a human. Then there is escalation. The goal is not to place a person behind every agent, watching every action. That would be like hiring an employee and assigning another employee to stand behind them all day. The system should instead recognize the moments when human judgment becomes necessary. Conflicting evidence, missing authority, unusual financial consequences, repeated failures, or a decision that cannot be reversed. This surrounding layer, permissions, memory, monitoring, orchestration, recovery, and escalation, will become the real operating system of the AI company. As models continue improving, their capabilities will increasingly overlap. One may lead in coding this month, another may become better at research. A third may offer comparable performance at a lower price. The leaderboard will keep moving. A company that builds its entire AI strategy around whichever model is currently ahead will be forced to rebuild every time the ranking changes. A stronger strategy is to own the execution layer. Design the workflow first, decide what successful completion looks like, what information the agent needs, where authority begins and ends, and which failures require intervention. Then choose the models that fit inside that architecture. One model may handle difficult reasoning, another might process large volumes of routine work. A smaller system could monitor performance or verify outputs. The models can change. The organization's workflow, institutional knowledge, governance, and evaluation system remain. That is where durable advantage will be created. Your competitors may gain access to the same model on the same day. They will not automatically possess the years of operational knowledge required to use it safely and effectively. For years, executives have been encouraged to ask which AI model they should use. That question is becoming too small. A better starting point is to ask which business process should be redesigned around autonomous execution. Find work with a clear beginning, a measurable end, and enough repetition to matter. Map how the process really operates, including the exceptions, informal decisions, missing data, and hidden work that never appears in the official diagram. Give the agent a defined role with limited authority. Measure whether the business outcome was completed correctly, not whether the model produced an impressive response. Most importantly, assume that failure will happen. The organization that knows how to detect, contain, and recover from failure will move faster than the one that simply hopes the model is intelligent enough to avoid it.
The current wave of model releases is impressive, but the most important competition is happening underneath the headlines. OpenAI, Anthropic, Meta, and xAI may continue trading positions at the frontier of intelligence. The larger prize will go to the companies that learn how to convert that intelligence into reliable work. The first era of generative AI gave us machines that could explain, write, analyze, and advise. The next era will bring systems that investigate, coordinate, decide, and execute. That transition will not be won through better prompts alone. It will require boundaries, memory, visibility, recovery, and a carefully designed path between an instruction and the finished result. The smartest model may change every few months. The ability to turn intelligence into outcomes will be much harder to copy. The model race is not truly disappearing. It is becoming the engine beneath a more important contest. The AI execution race has begun.